Welcome back to ARC Tutorials. This is AI tutorial series for absolute beginners. In today's episode, I'm going to talk about the different types of AI learnings that you should know and be aware of. Whenever we are learning about AI models or anything, AI learning is the most fundamental and basic concept that comes into play. And there are different mechanisms, there are different types that I'm going to cover. Let's get started. The first and the foremost is called supervised learning. Now, this is something where we label the data. Let's say you have a large data set and you label them manually. How did ChatGPT or Meta or any Google, any of these companies have trained the models? Is the first step is supervised learning. They had outsourced all the labeling work to a company called Scale AI, which later Meta acquired it. That company would label all the data on a huge, large scale level. That is what is called supervised learning. That means you are teaching AI using the labeled data. Each input comes with a correct output, which is a label basically. The AI learns to map inputs to certain outputs which are predefined or labeled. For example, when you're predicting house prices from features like size and location, you know that it has to be in certain range or this has to be the value. This is usually used in spam detection, credit scoring, and image classification. The model improves itself by minimizing errors on labeled data. This particular learning works really well for predictive tasks where you have the past historical data, and based on that you can analyze and come up with a label or a value or a number, right? Now this can handle regression. That means it can produce continuous outputs or classification. Now this is where when we talk about output is classification, it will tell you whether it's a cat, dog, human, etc, etc. So that is the classification. It helps AI learn patterns from examples which are already labeled. Okay, so remember, in one line, if you have to remember, supervised learning is where AI learns using the labeled data. The opposite of that becomes unsupervised learning, which is when you train your AI model on unlabeled data, that becomes unsupervised learning. In this particular model, the AI finds patterns and structures on its own. For example, it can group a number of customers and check their buying habits, or if you are talking about an enterprise, you can calculate and see what type of behavior certain customers are showing, which is called clustering. It's usually used in market segmentation, anomaly detection, and data exploration. It can reduce data dimensions using techniques like PCA. It can help discover hidden relationships in data. Like I said, this is an unlabeled data. It can be of any format. It can be JSON, text, PDF, etc. So there is no guarantee that the output given is correct, because since it's unlabeled data, the model is trying to derive patterns, derive structures out of that unstructured data, unlabeled data. So there are two concepts that it will learn from. One is called similarities and the other is called differences. It's particularly useful for data analysis and feature discovery. It can work extremely well for large complex data sets. The third type of learning is called reinforcement learning, which is you teach AI by trial and error method. So here the AI learns by receiving rewards or penalties for actions. For example, let's say you're training a robot to walk on a certain path. If it makes a mistake, you correct it. So next time the robot knows that I need to take this particular path. Same way, when you are training AI, let's say to create a game, let's say chess, in that if it makes a wrong move, you correct that and say that no, this is the correct path, right? So that's basically trial and error. Now it's heavily used in gaming, robotics, and recommendation systems. In this particular thing, the AI explores different actions to maximize the cumulative reward. That means different actions. It can have multiple permutation and combinations of action. if I move a particular, say, step in chess, what would be the outcome? If I take the other way, what would happen? So these are the different actions that would result into a maximizing your cumulative end reward. Now, this helps in balancing exploration, which is trying new things, plus exploitation, which is using the learned strategies. So, remember these two words, trial and error, and exploration and exploitation. Now, requires an environment to interact with. It can handle sequential decision making problems. It works well with complex tasks that are hard to label. Here, the AI will continuously learn the new strategies and optimize the behavior which is with the existing strategies. The next is called self-supervised learning. So self-supervised learning uses unlabeled data with generated labels. Now see, this is a combination of both supervised and unsupervised learning. So self-supervised learning uses unlabeled data with generated labels. The AI create tasks from raw data to learn representations. For example, in a given particular sentence, let's say, some words are missing. So that is where it would self-supervise and see that what he needs to be gathering from the unlabeled data that would go with the labeled data. That is also called masked language modeling. Now, this is the most popular technique that works in AI transformers and LLMs and computer vision. It helps AI to learn useful features from massive data sets. It reduces need for manual labeling. It can be pre-training step before supervised learning. It works well with text, images, and audio. Most of the things that you see, ChatGPT, Gemini, BERT, all of this are based on self-supervised learning. Now then there is something of a subset called semi-supervised learning. Now here we use a very particularly small amount of labeled data with a large amount of unlabeled data. Again, these are all broken down into subcategories, but you should know that there is something called semi-supervised and self-supervised. So semi-supervised combines benefits of supervised plus unsupervised learning. It will really drastically help you reduce the data labeling cost. AI uses unlabeled data to improve the learning. It improves accuracy compared to using only labeled data. It can also apply pseudo labeling or consistency training. It works really well in domains like healthcare, natural language processing, or say pattern recognition, etc. Then there is something called online learning or continuous learning. Now here you have a model, you keep feeding new data to it. So instead of training the AI model from scratch, we retain what was already trained and then train on the newly arrived data to adapt to trends and patterns in real time. Now this is important because the cost of training itself is pretty high. So you want to reduce that computational cost. Now this works really well, especially with time series, user interactions, or IoT. Now when we say time series, let's say stock market, right? That's one of the classic example of where everyday data changes, right? Or say certain product movement where the prices are going up and down on a daily basis. Or it can also be user interactions, like say buying a particular pattern, click, view, etc. Now this helps AI stay up to date with evolving data. That's why this is a must whenever we are training our AI models. The last is transfer learning. Now this is a kind of AI where we train the AI to reuse the knowledge from one task to another, which means you are reducing your training time and data requirements. You run particular thing, it derives an output from a particular task, and that becomes your input to the next model, right? So here we often use the pre-trained models as a starting point. There are a lot of open source pre-trained models which are available for anyone to download and start working. One, I would say the starting point for you should be the Hugging Face models. Those are the commonly available ones. You can also, this particular technique also helps generalize knowledge across different domains. Now, transfer learning is used in NLP, computer vision, speech recognition, especially with, say, neural networks, right, where one node passes data to another. And now this makes the overall AI development faster and more efficient. Those are all the different types of AI learnings that you should be aware if you're starting your journey with AI. Thank you so much for joining in this episode. I hope you like, share, and subscribe to my videos. Please write to me at surya.aradhya@gmail.com if you have any doubts. Thank you.